Stuttering is a speech disorder that affects over 70 million people worldwide. It is characterized by prolongation of sounds, interruptions in speech, and repetition of words, sounds, or syllables. It might arise in children as they learn speech and language skills, or result from a stroke, trauma, or other forms of brain injury. So why do neuroscientists look to songbirds when studying it? As it turns out, just as we humans learn our words from our parents and educators, songbirds do the same. And here we speak of the zebra finch, which learns its song as a juvenile from a tutor, and then practices it over time until it is crystallized as an adult song. In both songbirds and humans, auditory feedback is necessary for the vocal learning process. Continuous delayed auditory feedback is a technique that robustly disrupts speech fluency in normal humans. In songbirds, CDAF exposure induces mild to severe forms of stuttering and can cause substantial changes in their motor program for syllable timing generation. Researchers in the field do this by recording a bird's song via a microphone, delaying it by a few milliseconds, and playing it back to the bird in real time. The problem with using a microphone is that the recordings are contaminated with airborne sounds. So, to combat this, researchers have started implanting an accelerometer onto the skull of a bird and using bone conduction to record its vocalizations. As you can see here, the recording is not contaminated with airborne sound. The problem with that, however, is that the songbird cannot move freely in the cage. It suffers from continuous discomfort as it is tethered to a cable, thereby affecting its rate of song production and quality and rendering the scientific results obtained questionable. On this behalf, we propose the development of a Bluetooth-enabled wearable device that can record, process, and transfer vocalization samples. The device would also be able to induce CDAF variations and record the expected response. The first prototype circuit that we came up with is composed of three parts: a microcontroller, a micro SD card module, and the accelerometer. The accelerometer sends data to the microcontroller, which in turn saves it on an SD card. Then the data from the SD card is transmitted via Bluetooth to a mobile application or a server. The next prototype is a printed circuit board, or PCB, that contains all the necessary components for a wirelessly functional circuit, optimized spatially to make it take as little space as possible. The PCB will be sewn onto a little vest that will be fitted onto the bird and is ergonomically comfortable enough so that the bird can fly. The device will be tested on adult zebra finches by using it to induce CDAF and look at changes and abnormalities in the song's temporal and spectral features post-CDAF induction. If you are interested in learning more about this or would like to have a discussion, feel free to check out the poster below or to book a discussion with me. Thank you, and I hope you enjoyed.